In this video, we will continue defining our face turning job. In the technology page, we can define a face turning mode. It can be either a front face turning or a back face turning. When looking at this part, it is clear that we want to achieve a front face turning. For the working area, we can use the stock and recognize automatically the updated stock and generate a toolpath by it, or we can use our target and extend it by, for example, 15 millimeters and try to recalculate. Now, our face turning is extended by the 15 millimeters from the target, and we have here 15 passes because our step over is 1. If we put here our step over to be 3, it is clear that we will have 5 passes. For the direction, it can be a one-way direction, which looks like this, can turn only in one direction, or it can be a zigzag, where we are doing face turning in a zigzag motion. For this job, let's use a one-way direction. Here, we can turn on and off the roughing on our operation. For the rough type, we can either use stairs or a smooth method. We'll use stairs for the face turning here, and the smooth method will be explained more detailed in the turning job. For the step over, we set it to 3, but for our final steps here, if we activate them, we can say that we want at the end to have 5 cuts with a step over of 0.1. If we calculate now, at the end we will see these 5 cuts here with a step over of 0.1 millimeter. Now, if you take a look also at the last line of the toolpath, it is in front of the target, and it is exactly by 0.2, which is our offset. The offset here defines the offset from the target model for the stock that we leave for our finishing strategy. For example, we have 2 modes here. Let's try using Z mode and inputting minus 0.2. If we recalculate the job, you can see that we are cutting into the target. But if we select Z absolute, this will not allow you to cut inside the target, and it will see that you are not cutting directly in the target. For the retreat distance, is the retreat distance in each pass. So if we put 0.5 here you can see, if we recalculate the job, that 0.5 millimeters will be the distance between each pass here. At the end, in the technology page, you can define the finish strategy, and you can define either do you want compensation or not on your finishing pass. If we recalculate now, we can see that we have a finishing pass directly on the target model. Now let's go and create correctly this. So we will put on the stock, we will say 1 millimeter without the final steps, with the finishing, and the retreat distance we can say 0.2, and recalculate our job. Okay. Let's go now into our links and see what we can do here. For our approach point, we can go from the right safety corner, but if we don't want to end in the right safety corner, we have options here. We can end, for example, in X. We can say only X and input the X in diameter mode. For example, 180 millimeters. Let's recalculate now and see where our endpoint is. It is exactly here. Okay, so you have here different options. You can go only Z. You can go to the left safety corner. You can go Z first, then X, for example. But if you want to keep it the same as approach point, you have also a button here, same as approach point, and you can recalculate. Next thing to do is to create lead in and lead out. We will use the same lead out as lead in, and for the lead in, we can either set normal, arc, or tangent. Let's select we want to go with the arc and just recalculate this. As you can see, we have now our approach or our lead in with the arc. Now let's just go and turn this off since we will not be needing it for our face turning job. And at the end, we have miscellaneous parameters. Here, you can input a message that is connected with this job if you want to say something in your G code, or you can have extra parameters that are defined per VMID. And for example, here we have optional stop. Do we want it at the end of our job or not? Thanks for watching this video, and see you in the next one.